In this section, we will talk about the details of how users might interact with attribute providers and how relying parties interface with attribute providers and relationship providers via APIs. So as background, before you watch the session, you might want to have watched the session on OpenID Connect and Account User, but you should certainly have watched or read the slides from the Street Identity site about the economics of attribute providers and the business challenges, which talks about relationship managers. If you also want to follow along with the slides for this, you can go to streetidentity.com, visit the working group, and there's a file called API Interaction for Street Identity, which you can use to follow along with today's content. We also suggest subscribing to the mailing list link from the working group. So the end goal is that there are a lot of websites out there that might want to have access to verifiable information about a user, such as their age, citizenship, or the street address, where they live. And the idea is that there are other companies out there who could verify these attributes, called attribute providers, and who might then charge the websites who see value in that information. So let's take a specific example here, and we're going to walk through the flows of how a user might go to a website, share some information with that site, including a verified attribute, and use it to get something that's valuable to the end user. We're going to walk through all the steps that involved. So the example we're going to use in this scenario is a user, Sarah, who wants to log into a website to watch some premium online media content, maybe for a channel that she's subscribed to on her home TV. And in this case, she would go to the website and start off by wanting to sign in. And the user experience for that is talked about in other places with OpenID Connect and the account user. But the general idea is she would give some indication of what account she wants to use, and then she would be bounced in step 2 to her relationship manager, who would ask her if it was okay to share some information with the site. In this case, the site wants to first get her verified street address information, which it needs to confirm she's a paying subscriber for this content. The second, to get some basic information about her account, maybe her photo to show to her, as well as to verify her email address so the site can keep in contact with her. One thing to notice in here for us techie geeks is the OAuth2 word there in the URL that you can see. So this page is started via an OAuth2 flow, in particular using a few scopes, one to get a user's email, one to get a user's address, and another one for OpenID Connect to get the user logged in. Assuming the user gives their consent, the next page that they would hopefully see is the site saying, oh great, you're known, your address known, we're able to find out you're a verified user and payer for this content, and so the user would see the content. And in some cases that would happen, and we'll show how at the end the user gets that point. But maybe the user comes here and the site goes back to Relationship Manager, and even though the user gave access for the site to see their list of verified street addresses, the user has none yet. And that's what happened in this case. The relying party made an API call to the Relationship Manager, asked for a list of verified street addresses. There were none. And so it shows a page to the user here saying, I'm sorry, your subscription status is unknown. And near the bottom, it lists some of the attribute providers that it trusts to verify the user's street address. So the user could pick one of those, and attribute providers could come in many different forms, many different companies. But for our demos, we have a set built by a company called ID DataWeb that shows how a user might verify their street address by, on a page, entering their home street address, which user does on a screen like this, and as soon as they submit it, what happens is ID DataWeb sends a postal card to that address with a one-time code on it. So the user, a few days later would receive that postal code, and it would tell them to please come back to the web page, enter that code, and in doing so the user has now verified that street address attribute. Well, the next thing that happens is that the attribute provider needs to get permission to add that information to the user's account at their relationship manager. In this case, we'll use Google as the example of that relationship manager. So the website goes through another one of these OAuth2 consent flows to get the user's permission to add that verified street address to the user's relationship manager. So on this consent screen, you'll notice that the last line down there is not to only view the user's list of verified street addresses, but to actually manage that list so that the attribute provider can add a new entry to it. Assuming the user does give consent, the attribute provider, now using standard OAuth 2, secures an API call to the relationship manager's service that supports the list of street addresses, and it passes in at least a descriptive name of that address, as well as, of course, identifies the attribute provider itself. And then one important thing is it's going to provide a numeric identifier that is actually a mapping into the attribute provider's database where that actual address is stored. Now, maybe the actual address is passed up to the relationship manager, maybe it isn't. In many cases, it's not actually necessary, but later on in the slides, we'll talk about some cases where maybe it is. But for now, let's just assume it isn't. For now, let's assume the attribute provider just added an entry with a descriptive name, a ID that's a handle back into the attribute provider's database, and the relationship manager via OAuth was able to identify the actual attribute provider. So it has those three pieces of information. Well, now, if the user goes back to that website where they're trying to access the premium content, in this case, the website says, oh, well, your subscription status is unknown, but now the website has been able to make a call to the user's relationship manager and get a list of verified street addresses. And it finds out that there is one with the descriptive name of home, and in this case, the user, wrote a little note called it's their, Johnson house, or maybe it's Johnson Street, Johnson City. It's up to the user. And in this case, the relationship manager identifies the attribute provider who verified this information as being ID DataWeb. So the user has a button they can click next to that address saying that they do, in fact, want to use that address to confirm their subscription status. Now, of course, the website could have just used that one automatically, but we wanted to show this level of detail here so you could understand the flow. So what happens after the user selects that address or the website wants to check it? Well, now the relying party goes back to the API that provides the list of street addresses and says, hey, I'm interested in this home address that came from the ID DataWeb attribute provider. Please give me a token that I, in this case the user ID TV website, can now use to make an API call directly to the attribute provider to get the actual verified address. So when that request is made, the service provider verifies that the user has previously given their consent to share that type of information, so it does give the token to the website. Now what next happens is the website sends that token to the attribute provider. The attribute provider verifies that it's accurate, and it looks up that unique ID or handle that we mentioned before. That's a mapping into the attribute provider's database. It uses that to find the actual street address. It finally returns that information to the website, so the website now has a verified street address for the user or other attribute. One of the important things to note here, though, is that the attribute provider also at this point bills the relying party based on whatever relationship they have with each other, but there's now money being exchanged. Now the actual details of how the attribute provider validate this token that comes from the service provider to the relying party and back to the attribute provider is actually complicated. There are quite a number of steps that the attribute provider has to do to verify the token, and this is why there is a working group at the streetidentity.com site to document the best practices here to make sure that attribute providers don't have security problems. So there are a list here of a bunch of steps that need to be performed. Some of them have to be performed by the attribute provider. Some of them the attribute provider could outsource back to the service provider by sending the token back to the original service provider who issued it. But they need to do a bunch of things like make sure the OAuth 2 signatures are valid, make sure that the relationship manager that issued it is one that the attribute provider supports, check the timestamp on the token, make sure that the attribute provider listed in the token is the one who actually is the attribute provider who received the token. Similarly, make sure that the relying party in the token is the same as the relying party who contacted the attribute provider. as well as checking the scope to make sure it's for the right address, and then of course finding that numeric ID that's a mapping into the attribute provider's database for the actual entry. So a bunch of complicated work there for the developers, but for the end user it's still just a couple clicks. So let's assume that the website now finally has a verified street address for the user. What would they do with that? Well, it's going to depend on the website. Maybe the website is a hospital who has a direct billing relationship with that user, and it goes into its database and says, oh, I have some healthcare records for the person who lives at that street address, and it shows them to the user. Or in this case, maybe it's the online website of a cable company who can go directly into its customer database, determine that, oh yes, that the person at that address is a paying subscriber and share the content. Or maybe it's a more indirect relationship. Maybe this website isn't run by the cable provider, maybe it's run by an individual TV channel, so that TV channel then, with that verified address, needs to poll the cable or satellite providers in that geographic area, ask if any of them know whether there's a paying subscriber at that address. If the TV site is able to determine that yes, in fact there is, a paying subscriber at that address, well then fine. Now finally the TV website can show the premium content to the user, and it probably would also want to acknowledge what the name was of the cable provider or satellite provider that the user is paying for the service. But for the end user, the end result is they now have access to their premium content with just a few clicks. One of the other things to note is, we talked about the money flowing back and forth here and the role of this relationship manager. So, we show that the relationship manager, one of their jobs is just to get the user's consent. Consent to share information with the relying party, consent for the user to be linked to a new attribute provider. One of the other things the relationship manager does is it has a website where the user can go back to and just get a list of what are the verified street addresses in their account, and what other web services have access to either read or write their list of addresses. To help fund the creation of such services, it may be that the attribute provider gives some percentage of the money it receives from transactions to the relationship manager. So hopefully you followed all that. If not, feel free to pause and go back and listen to it again. And we're now going to switch and just talk about some of the common questions that come up about this scenario. And we're going to start off with some issues around content and usage rights. Because one of the common questions is a company who says, oh, I have a user's street address and I verified it. I'd like to become an attribute provider. Okay, maybe you're interested in doing that, but now you better check with the orders and find out, can you be an attribute provider? Can you pass that verified value onto another website? For example, maybe your company paid some other company to verify that street address. If so, your legal contract with that other company may prevent you from sort of passing on that information, and certainly passing on in a way in which you make money from it. One specific example is, imagine the website in the previous examples, User ID TV. It has now received a verified street address, for the user from that upstream attribute provider. Well, that attribute provider doesn't want User ID TV to then be giving that out to other websites and charging for it. So frequently there are legal restrictions on the ability to pass on this information that was costly to verify. The next thing is, oh, okay, well, my website has verified information on a user, and we're confident that we have the ability to charge and pass it on. Well, then the next question is, well, under what circumstances are you allowed to give out information about the user, from a privacy perspective? Here, the key advantage is that the OAuth 2 model is one that's already proven both in the technology, privacy, and legal world to be a good model for getting consent from the user to share information. It's already used, for example, for sharing healthcare records back and forth in products like Microsoft Health, Google Health, etc. And so as noted here, it meets very strict definitions of user consent. Now, of course, because there is usually no laws that say, okay, with an OAuth 2 style dance, this attribute can be given out. Usually it's not that clear, so you're going to need to have your legal team go back and analyze, exactly where you are. sometimes that can be difficult for them. It's hard to go through all the laws and prove there's no law written down that says your business can't use a no-auth type flow. But as described before, it's already been used to share much more sensitive information like health information, and so the model has been shown to be broadly applicable in a legal sense. Now, the next question tends to come up is, great, your company verified a user's street address, but how did you do it? Because the websites that are relying on your verification are likely to care how you did it and may in fact be willing to pay different amounts of money for how you did it. Because did you do it by sending a postcard to the user? Did you do it in person by checking a government-issued ID? Did you do both? There's another scheme sometimes used called knowledge-based authentication, where you interrogate the user online to ask them questions that would probably only be known by the person who lived at that address. I say probably because, of course, there's no guarantee in any of these things. And so attribute providers normally need to tell relying parties how they actually did the verification, and the relying parties might not trust all those schemes or maybe wanting to pay different amounts for different types of verification. So then, if you are an attribute provider, you might wonder who are going to be other attribute providers, who's your competition. And there are many different companies who could get in this space. Some of them have pretty well recognizable brands, that users might notice, like the United States Postal Service if the person lives in the United States, or Equifax, who's a public credit agency. So these are businesses that are good at verifying users' information, like a street address. There are other websites that also have very well-known names to user, like a Verizon, AT&T, Bank of America, Citibank, etc., who, generally speaking, have verified the street address of their customers. And one of the nice things is, unlike the United States Postal Service, the user might already have a login for, say, their mobile operator or cable provider or bank. So they could just log into that website, who's already verified their address, and just ask them to pass it up to their relationship manager with just a few clicks. They don't even have to wait for an additional verification process. Employers also fall in this example. Employers usually have verified a user's street address, and almost all cases employees have a login to their employee's website. Now, there are also attribute providers like Google and Facebook, who are not traditionally in the job of verifying actual real-world identity information. They usually focus more on the virtual world, and so they could potentially go out and directly incur the costs of identity verification of users and then charge websites to do it. And the question comes up of, should they do that to try to bootstrap a multiplayer market, or should they take more the approach of being a relationship manager who helps connect attribute providers to relying parties? All these different forms of models are possible. Another common example comes up is one company might be interested in being an attribute provider. They might have a good way to verify users, but they might not want to invest in all of the technology to support all of this complicated OAuth flows and tokens and security issues. So they may pay another IT firm like IT DataWeb or others to actually run much of the infrastructure for them, especially the billing components. The next set of questions that commonly come up are around things that are actually up to the relying party and attribute to figure out. So, what's the cost? And what's the contract that's signed? Those things are left up to the relationship between the relying party and the attribute provider to negotiate. There are not, at least to start off with, global pricing schemes or global contracts that are expected to be signed. Instead, it's going to start off with one-to-one pricing and contracts. Now, there may also be a contract and some economic relationship between the attribute providers and the relationship managers, because the relationship managers may want to only support attribute providers they feel are of a certain quality, and they may also need to recover some of their costs from operating the service. Now, over time, hopefully this model will be so successful that there are lots of attribute providers for the same attribute, and in fact, lots of different relationship managers. But it would become very complex for a single relying party website to have to deal with multiple relationship managers who then connect to multiple attribute providers. So generally when that type of complexity exists, what you see start to happen is the creation of middleman services, which in this case we'll refer to as an attribute processing network. That's a service that a relying party website might contract with to help handle the job of then connecting out to all the different relationship managers, attribute providers, etc. And once there are sort of these middleman services, they can help gloss over the fact that maybe not everyone does the protocol details exactly the same way. And maybe there's some complexities about how the billing should be handled. So maybe a relying party just gives money to the attribute processing network, who then handles upstream payment. So hopefully we will get to the point where these types of services are needed and are popular. However, one of the challenges that exists there is how does the relying party website know what attribute providers to trust if there are a large number of them and there are a large number of relationship managers? Well, this is a focus that organizations like the Open Identity Exchange have focused on, where the Open Identity Exchange and others like it try to help organizations create certification frameworks, sort of checklists that service providers have to follow, and then find another set of companies that can audit and certify businesses as meeting those checkboxes. So we generally refer to this as certification. So a attribute provider might be certified as meeting certain requirements. This also is a thing that enables the building of common contracts. So maybe that the attribute provider is certified that they follow certificate criteria XYZ, and part of that criteria is that the attribute provider accepts a standardized contract, maybe even standardized pricing protocol, etc. Now again, assuming all that works, and there are that many attribute providers, there may be circumstances where the user has multiple attribute providers, and the relying party detects that. Well, now it has to decide which ones to use. Now, the first thing it could do is just filter the attribute providers to just the ones it trusts, and the ones that meet the certification requirements it has. It might also sort them based on pricing. Maybe there are 2 attribute providers for a user that it trusts, but one of them is cheaper than the other. Now, the next challenge is, what if the user does have multiple attribute providers and they've actually verified the same address? Well, in that case, the relying party certainly doesn't want to pay both attribute providers to get the same verified information. That would be inefficient. So in the future, there may need to be a way for the relationship manager to realize that multiple of the addresses are actually the same one. Now, the obvious way to achieve that is for the attribute providers, when they add an address to the relationship manager, to pass up the actual verified street address. That way the relationship manager can see if it matches an existing one. Now that takes away one of the theoretical privacy benefits of the relationship manager not actually needing to know the address. However, from a usability standpoint, there's a lot of data that would indicate the users, when they visit the relationship manager, need to see a list of the actual verified addresses to understand which ones are being used by which websites. So hopefully the information we discussed here gives you a pretty good understanding of how the attribute provider model might work, both in terms of user flows and APIs. And this model is constantly evolving. So if you're interested in learning more, we hope you'll go to streetidentity.com and you can subscribe to the mailing list there, as well as there's a lot of additional content that you might take a look at. Thank you for your time.